Hello everyone. In this video, I will explain the exponential laws, which is useful for the students, those who are studying 7th, 8th, 9th, 10th, 11th, and 12th class students also. I will explain the concepts from bottom to gradually up to Olympiad level. In each video, I'll increase the difficulty level of the problems. This video particularly about the basic concepts of exponential laws. So here you see, suppose you take a square of side length, let us assume 10 units. So then we write that area of this square equal to 10 into 10. So instead of writing 10 into 10 two times, simply we write this as 10 square. So we read as a 10 squared or 10 to the power 2. Another example here you see, you consider a cube whose side length is 10 units. Okay, this is 10 and this is also 10. Then what is the volume? Volume of this cube equal to, we write 10 into 10 into 10. So simply we denote it by 10 cube. We read as a 10 cube. This one is 10 squared. So here 10 is multiplied 3 times. So we write 10 to the power of 3. If 10 is multiplied 4 times, we write 10 to the power of 4. If 10 is multiplied 10 times, we write 10 to the power of 10. So here consider, let A be an integer and M and N be two non-negative integers. So first I'll explain the exponential laws only for integers. After that I'll extend for any real numbers. So here you see the rule number 1 is a power m, nothing but we write that a into a. How many times we multiply the same quantity? M times. So a into a and so on m times we write simply a to the power of m, as in the case of you see volume of cube is 10 cube. Now what do you call a and what do you call m or m? Here you see in a to the power of n, this a is called base. This is called base. And whereas this power, this n is called, this is known as a power or index or exponent, or you can say exponent. So a to the power of n, we say that a is the base of this expression and that n is called a power or index or an exponent. Either power, index or exponent. So here we have two things. One is the base and another one is an exponent. And we read a power n as a raised to the power n or a to the power of n or simply a power n. So here a is multiplied m times. So we write a to the power of m. So one example here, 3 into 3 into 3 into 3 into 3. Suppose if I multiply 5 times, then we write simply this as 3 is multiplied 5 times. So we write 3 to the power of 5. Now the second one is a to the power of m into a to the power of n. This is equal to a to the power of, we add the indices, a to the power of m plus n. So the proof of this one is quite simple. Here you see that a to the power of m into a power n. So first one, a is multiplied how many times? M times. So this is m times up to a here. This is multiplied m times. And the same quantity a is multiplied. This is multiplied n times. So same quantity is multiplied m plus n times. So this is nothing but a to the power of, we are multiplying a m plus n times. So we write this is m plus n. So one example, what is 10 square into 10 to the power of 4? So simply we write that 10 to the power of, add the exponents. So this we get 10 to the power of 6. Here 10 is multiplied 2 times, here 10 is multiplied 4 times. So totally 10 is multiplied 6 times. The third one is a to the power of m by a to the power of n. This we write as a to the power of m minus n. Particularly this quotient rule. So this is the product rule. And this one is a quotient rule. When we write this quotient rule, take care of that here base is not equal to 0. Where base A is not equal to 0. So I'll explain this quotient rule using a simple example. For example, 2 into 2 into 2 into 2 into 2 whole by, let us take 2 into 2. So what we can write here, you see, you can cancel like this. So this is equal to 2 to the power of 2. So here the left side one is 2 to the power of 4 in numerator, denominator 2 square. So we got this is equal to 2 square. This is nothing but 2 to the power of upper exponent minus denominator exponent. This is equal to 2 to the power of. Or I can give another example that 3 to the power of 5 by, let us take 3 to the power of 2. So this is nothing but we multiply 3 5 times in numerator whole by 3 into 3. Simply you can cancel 113. So this we got 3 power 3. Nothing but we just subtract that denominator exponent from the numerator exponent. Numerator exponent is 5, whereas denominator exponent is 2. So we get 3 to the power of 3. So a power m by a power n equal to a to the power of m minus n is a very, very important rule. Now we define a power 0 equal to 1. We define a power 0 equal to 1, where a is not equal to 0. Where a is not equal to 0. So any number power 0, that any number should not be 0, we define as a 1. So now what happens if we have a negative power or negative exponent? Negative power or negative exponent. We define that 1 by a as, we write this as a to the power of minus 1. 1 by a we write as a to the power of minus 1. So for example, 1 by 2. So simply we write this as a 2 to the power of minus 1. Or 1 by 10. We write this is 10 to the power of minus 1. Here a is not equal to 0 because we are writing 1 by a. So now when we multiply 1 by a some n times, then how do we express? So this is the for negative exponent. Here minus 1 is the negative exponent. The latter one is 1 by a to the power of m. 1 by a to the power of m. We write, you see, this 1 is written as a to the power of 0 by a to the power of m. This is equal to, just you see the quotient rule. Here you see that a to the power of m by a to the power of n equal to a power m minus n. So the same concept can be applied here. So this we write a to the power of 0 minus m. So therefore this is equal to a to the power of minus m. For example, like this, 1 by 3 into 1 by 3 into 1 by 3. So this we write 1 by 3 cube, or else you can write 3 to the power of minus 3. The next one, very important one, is a to the power of m power n. A to the power of m power n. This we write a to the power of, multiply the exponents m into n. This is also written as a to the power of n power m. So here proof is quite simple. A to the power of m whole to the power of n means you have to multiply that a to the power of m n times. So a to the power of m, a to the power of m, and so on. How many times? N times. So using that product rule, here we have to add these powers how many times? N times. So this is equal to a to the power of m plus m plus m plus and so on. We have to add the same quantity n times. So this we got a to the power of m is added n times. So we can write that m into n. Remember, this is not same as of a to the power of m power n. So note. A to the power of m power n is not same that a to the power of m power n. Both are quite different. You can see through an example. 2 square whole cube. This is nothing but 2 to the power of 2 into 3, 2 to the power of 6. So this we write 64. Whereas what is 2 to the power of 2 power 3? So when you are expanding this expansion, you have to come from up to down like this. So this is nothing but 2 to the power of 2 cube is 8, 2 power 8. So this is 2 to the power of 6 and this is 2 to the power of 8. So therefore, that 2 square whole cube is not same as 2 to the power of 2 power 3. I'll give one more example. What is minus 1 whole to the power of 2n? Okay, this is equal to, where of course n is a non-negative integer. So this we write as using this concept. A to the power of mn can also be written as a power n whole power m or a to the power of m whole power n. So using that concept, you say this I can write minus 1 whole to the power of 2 into n. So this we write minus 1 to the power of 2 into n. Observe clearly, we can write as minus 1 whole square whole to the power of n. Minus 1 whole square means minus 1 into minus 1 plus 1. So 1 power n is always 1. Minus 1 whole to the power of 2n plus 1. So using the above concepts, this I can write minus 1 to the power of 2n into minus 1. We know that minus 1 whole power 2n is 1. So this is 1 into minus 1. This is equal to minus 1. So this particular thing is very, very important. We use minus 1 whole power n very frequently in mathematics. Hence, we can write minus 1 whole to the power of n equal to, where n is a non-negative integer, or you can take an integer also. So it will be 1 if n is even integer. If n is even. Right. So here I am writing that n belongs to Z. And it is minus 1 if n is an odd integer. N is an odd integer. The above exponential relations or exponential laws can be extended for any real numbers under some constraints. I have just explained those rules only for non-negative integers, but these exponential rules obeys even for non-negative, non-positive integers also, means for negative integers also, right? For example, 2 to the power of minus 2, we write 1 by 2 square. 10 to the power of minus 8, we write 1 by 10 to the power of 8. So they are valid for even for negative integers. Now what happens if the exponents are real numbers? Real numbers means it includes integers, rational numbers, irrational numbers. Means you can have the power 3 by 2, minus 2, minus 3, minus 3 by 4, or you can have the power root 2, root 3, root 5, etc. So here a is a positive real number. When we are explaining in terms of any real numbers, you must take care that a must be a positive real number. Positive real number, and x and y be any real numbers. So a to the power of x, this is nothing but a is multiplied how many times? X times. A into a into a. This is x times. The proof is beyond our scope, so I do not give any proof. The second one is a to the power of x into a to the power of y. This is nothing but a to the power of x plus y, right? Product rule. So I can give you an example like 2 to the power of 3 by 2 into 2 to the power of 1 by 3. So you can simply write 2 to the power of same base. So add the powers plus 1 by 3. This is nothing but 2 to the power of 9 plus 2, 11 by 6. So third one is that 1 by a to the power of x or a power x by a power y. We write simply a to the power of x minus y. For example, you take the 10 to the power of 3 by 4 whole by 10 to the power of 1 by 5. So this is nothing but we write 10 to the power of 3 by 4 minus 1 by 5. So this gives us 10 to the power of here 15 minus 1, 14 by 20. You can simplify it. The fourth rule is that 1 by a to the power of x, I can write a to the power of minus x. Remember, we have taken that in all these cases, a is greater than 0. There is no restriction on the powers. The fifth rule is that a to the power of 0 equal to 1, where of course a power 0 equal to 1, where a is greater than 0. The sixth rule is a to the power of x whole to the power of y equal to same as of previous one. This is a to the power of x into y. So these exponential laws are valid only for positive real number. Base must be positive here. Remember, and x and y are any real numbers. So note, for example, you take that minus 2 whole to the power of 1 by 2 is not defined. Is not defined. Similarly, minus 3 whole to the power of 1 by 4 is not defined. We cannot evaluate these values. So sometimes these values can be evaluated, sometimes these values cannot be evaluated based on the exponent. So that's why we take generally base must be positive. So in the next video, I will explain a few examples based on these exponential laws. I will increase the level of difficulty of questions.